Hi, welcome my dear students. It is nice to a forced gap, you can say, due to the corona scare, and we are taking abundant precaution to be off in our homes to avoid spreading of this contagion. So while remaining in our homes, let's begin our online classes, online tutorials, you can say. And today we shall be discussing the energy flow in ecosystem. So what is energy? Do you think that energy, how will you define energy? Energy, you can say, is an ability to do some work, and life itself manifests in the transfer, fixation, transfer, transmission, loss, and gain of energies. So, energy changes, you can say, drives the life process. So, let's first see that what are the relationships between living and non-living environment, and how we fix the energy and how we transmit the energy from one trophic level to the another trophic level. To begin with, let us have a look at the energy relations. The ecosystem, consists of both biotic as well as abiotic components. The biotic components are the living beings which live in their environment constituted by the abiotic components. And there are interrelationships, dynamic interrelationships between both biotic and abiotic components of the ecosystem, which results in the manifestation of life. So life results due to interaction between biotic and abiotic components of the ecosystem. And so what happens that the biotic components uh, have got the ability to fix the energy and transmit the energy from one trophic level to another trophic level. So the fixation of energy, its transference from one trophic level to another trophic level. Trophic level is the level of eating. Each level of eating is called trophic level. So the transfer from one trophic level to the another trophic level, and in course of this transfer, part of energy is dissipated, it is lost in the form of heat. Part of energy is utilized for carrying out the life process, and part of energy is then transferred to the next trophic level. So this transfer of energy, fixation of energy, its transfer from one trophic level to the another trophic level, and its dissipation. These relationships can be discussed under the heading of energy flow in an ecosystem. Now, this very simple diagram depicts that how energy relationship exists between different components of the ecosystem. So here you have got the sun. Sun is the primary source, or you can say the main source, predominant source of energy of our ecosystem. We are driven by the energy that we receive from the sun. So the solar energy is perceived by the plants, green plants. Green plants are called autotrophs. Auto self, troph means to produce their food particle. So the plants only have got the ability to fix the solar energy and to produce their own food. We people, we basically depend upon the food prepared by the plants. So the plants are autotroph. They are producer of their own food material by utilizing the solar energy. Then these plants or the producers are consumed by the primary consumers. Primary consumers are those consumers which depend upon the plant resources for their food. In other words, you can say that they are herbivores. they feed upon the plants. So those consumers which feed upon the plants are primary consumers. So the primary consumers consume the food produced by the producers, getting the energy from the solar radiation. And these primary consumers are again taken by primary carnivores. Carnivores are animal eating animals, and so they feed upon the herbivores, and they are themselves again fed upon by the secondary carnivores. And these carnivores, upon death and decay, they are subjected to the action by decomposers. These decomposers carry out the mineralization, that is, the organic matter is transformed into inorganic matter, and that inorganic matter is again made available for the plants to synthesize their own food with the help of energy from the solar radiation. So that is how the energy relation exists between different components of the ecosystem. Now, the fixation and passage of energy. So, the main source of energy is the solar energy. The main source of energy is the solar energy. While the solar energy, solar radiation impinges upon the earth, it is not that the earth absorbs the entire solar radiation impinging upon earth. Major part of the solar radiation that falls upon the earth is re-radiated back into the environment. Another portion which is absorbed by earth is also lost as a hit, perceptible hit. So only a part, a minuscule portion of the total solar radiation that impinges upon the earth is utilized by the plant for their food production. So how plants carry out food production? All of you know the process of photosynthesis. Photosynthesis is carried out by the green plants having chlorophyll, and they convert carbon dioxide with water by taking energy from the solar radiation into carbohydrates, and these carbohydrates serves as food not only for the plants themselves but also to the next tropic levels too. So the plants have got the ability to transform the solar energy into potential energy of the chemical bonds. Chemical bonds, the chemical bonds in their bondage conserve the potential energy that was gained from the solar energy. Since these plants have got the ability to prepare their own food, they are called producers, whereas those which sustain upon the food produced by these plants are called consumers. So the basic principle of flow of energy, or the direction of the flow of energy, is from producer to consumer. So the energy from the solar radiation is fixed by the producer for preparation of their own food, and that food is transferred to the consumer. So the passage of energy takes place from solar radiation to producers to consumers. Now this simple diagram shows that energy relationship, that here you have got the sun, the solar radiation is impinging upon the primary producers. Primary producers are the plants, they have got the chlorophyll, and they utilize the solar radiation by means of, mediated by the chlorophyll in the process of the photosynthesis, to synthesize carbohydrates, and part of the synthesized food is utilized by the plants themselves for carrying out respiration and for getting energy for sustaining their own life. So part of the energy is lost at the hit, and part is transferred to primary consumers, and primary consumers are the herbivores, that is the animals which feed upon the plants for getting their food, for getting energy. So the energy which was fixed by the plants, utilized partly for their own purpose, and the rest was utilized in the biomass production, and that part of that biomass is used by the primary consumers, that is herbivores, that means plant eating animals, and the part is also lost to decomposers, to detritus food chain that we shall be dealing with later. So primary consumers are the herbivores, then these herbivores are fed upon by the secondary consumers, and these secondary consumers are the carnivores, and they themselves are fed upon by the tertiary consumers, that is higher level, higher order of carnivores. And so you see that at each level it is lost. So the entire energy fixed by the primary producers is not available to the tertiary consumers. Instead, energy dissipates at each level of the transference, and so longer the chain, lesser will be the energy available to the final level of consumer. Now, before delving into the nuances, into the intricacies of the energy transfer in ecosystem, let's have a quick recap of the basic concepts. So, the energy transfer and dissipation and transformation involves what you say thermodynamics. Thermo means related to heat, and dynamics means some sort of transfer, so some sort of mobility. So thermodynamics. So this transfer of energy through the ecosystem follows or conforms to the laws of thermodynamics. So what are those laws? So for our purpose, certain laws of thermodynamics are concerned. So we should first deal with, or we should have a quick recap of those laws of thermodynamics before going into the details of the energy transfer, so that we can correlate that how this transfer is conforming to the laws of thermodynamics. So we have the first law, which is also known as the law of conservation of energy. That means energy can neither be created nor be destroyed nor be destructed, but it can be transferred from one level to the another level, that is one form to the another form. So while it is transferred from one level to the another level, it can be transformed from one form to the another form, but it can neither be created nor be destroyed. The second law of thermodynamics is concerned with entropy. So it shows that entropy of any isolated system always increases. That is, disorder in a system always increases. Entropy, what is entropy? It is a measure of disorder or randomness in a closed system. So as energy is transformed from one form or to the another form, it is wasted, it is lost, and the process of transformation is irreversible. That is, energy is not again made available to the previous trophic level. Once the transfer has taken place, it is a one-way system. Energy can never be made available to the previous level of the nutrition or the trophic level. The third law of thermodynamics says that entropy of a system approaches a constant value as the temperature approaches absolute zero. So as the temperature approaches absolute zero, the entropy also approaches a constant value. That is the third law of thermodynamics. Now, again, we should see about the production. So what type of production and what level or what extent of production is made available to the next trophic level. So the primary production is the production of primary producers or the autotrophs. The production of autotrophs is known as primary production, but it can be again subdivided into gross primary production and net primary production. What is gross primary production? The energy fixed by the plants, total amount of energy fixed by the plants is called gross primary production, which is equivalent to the energy fixed in the photosystem. So the energy fixed by the photosynthetic machinery of the plant is called the gross primary production. But the entire energy that the plant fixes is not made available to the next trophic level. In fact, the plant is fixing energy for sustaining its own life. So part of the primary production or the gross primary production is utilized by the plant for carrying out its life activities, for respiration and for other purposes. And so that part, if we deduct that part from the gross primary production, we get the net primary production. So net primary production is the gross primary production minus energy used by the plants for respiration. So gross primary production is the total energy fixed by the plants with the help of solar radiation mediated by the chlorophyll. But that total energy is not utilized for biomass production for the transfer. Major part of the energy is utilized for sustaining various life processes such as respiration, reproduction, and other physiological activity that plants carry. So the biomass production which is available to the next trophic level is only that part of energy which is gross primary production minus respiration, and this net primary production is the primary production which is available to the next trophic level. Now, the efficiency of gross primary production. What is the efficiency of gross primary production? That means by this we can gauge that how much of the energy impinging upon the plant is utilized by the plant for producing its own food. That is energy fixed by gross primary production divided by energy in incident sunlight. That is how much of the incident sunlight energy is utilized by the plants for production of their own food. That is the efficiency of gross primary production. Then there is a word detritus. Detritus, what is detritus? Detritus refers to the organic matters. Plants derive inorganic matters from the soil, and then by the photosynthetic process they transform those inorganic substances into organic matter in their food. Then various synthetic activities such as protein synthesis, etc., lead to synthesis of other organic matter. But when death and decay occurs, these organic matters are deposed upon the soil, and that is called detritus, and they are acted upon by microorganisms which are called converters or mineralizers, because they transform these organic substances into their basic components into the minerals which can be easily taken by the plants. So after death and decay, detritus, that is the dead organic matter, is acted upon by another set of organisms. So here a detritus food chain comes into picture. Now, going to the previous slide, you can see that I have written here, sun is the main source of the energy. I have not deliberately not written the sun is the only source of the energy. but it is the main measure or the predominant source of energy, you can say. So it implies that there must be some other sources of energy also upon which the living system must be thriving. So here is a sideshow, that is, and you cannot say that it is an accessory information, but it is a little bit offbeat information. Nevertheless, it is very important to know that there is a source other than sun, a source of energy other than sun too, and that source of energy is geothermal energy, which is uh, available in many warm springs also. But since the solar energy penetrate those springs, the solar energy, the organisms thriving in those ponds also depend upon solar energy. But there is a community of living beings which are thriving in the bottom of the oceans, and the sun never penetrates, the solar rays never penetrates and reach the bottom of the earth. So they live in perpetual darkness. So from where, the question arises, from where they draw their energy, from where they derive their energy to carry out, to sustain their life processes. It has been come to light in late 70s that while the bottom of the bottom of the sea is spreading, many geothermal vents arise, and they give rise to vents of warm water, including hydrogen sulfide, etc. And these organisms derive their energy from acting upon, from oxidizing those hydrogen sulfide. So sun, being the main source, is not the only source. At the perpetual darkness in sea floor, we can encounter hot sulfurous springs, and these springs have hydrogen sulfides and other sulfides, and there are many marine organisms which do not derive their energy from the solar energy. Rather, they derive energy by oxidizing hydrogen sulfide arising from these vents, and they are the mat of those microorganisms are fed upon by snails, small fishes, so on and so forth. So a small ecosystem and a very small food chain is thriving away from the solar radiation. It is not getting its energy from the solar radiation. Rather, it is thriving at the bottom of the sea, getting it their energy from the very bottom of the sea through the geothermal vents. So, my dear friends, it should be abundantly clear to you that sun is the predominant source of energy for our planet Earth, and without sun we cannot survive, as it is the ultimate source of the energy. But postscripts have also been written, and there are minor ecosystems which derive their energy not from this predominant source of energy but from other alternative sources. So you must have an idea that why I have written that sun is the main source, why I have not written that sun is the only source of the energy available. Next. Now let us come to the forefront of the energy flow in the ecosystem. And the energy flow, that is the flow of energy, takes place only after the energy is fixed. So as you have seen that the green plants, which are autotrophs, which make their own food, are the fixers of the energy available through the solar radiation. So only green plants have got the ability to fix solar radiant energy. And what they do, they utilize this energy to convert carbon dioxide, water, and oxygen into, carbon dioxide and water into carbohydrates. Oxidation of carbohydrates require oxygen. So what happens that carbohydrate by carbon and water utilizing solar energy, and the production by the autotrophs, the total production by the autotrophs utilizing the solar energy, as we have seen earlier in our basic points, is the gross primary production. This gross primary production is greatest in the areas which are warm and tropical rainforests are in abundance, and it gradually decreases as we move towards the poles. A portion of this food is oxidized for the production of energy for driving the life processes of the plant themselves, and over and above this energy is transformed into biomass, which is available to the next trophic level. So we can see that about 50 to 70% of the energy fixed by the photosynthesis is lost in respiration. The remaining, the net primary production, is available for consumers. So 50 to 70% of the total energy that plants fix utilize for themselves. That is the total, that is the primary production, gross primary production. 50 to 70% of gross primary production is utilized by the plant themselves, and only 30 to 50% of the gross primary production is available for the next trophic level. Now we shall see that how efficiently the plants utilize the solar energy for producing their own food, and that is known as efficiency of primary production. That is how efficiently the primary production is carried out. So the efficiency of utilization of the sunlight can be assessed by determining how much incident sunlight had been utilized by the plants. So efficiency, how will you determine the efficiency? How much solar radiation is impinging upon the plants, and what proportion of that impinging radiation is utilized by the plants for production of their food, and that is the primary efficiency of the primary production. So it can be calculated by dividing energy fixed by plants as gross primary production, that is energy that has been fixed by plants for gross primary production, divided by energy in the incident light. So if we divide the gross primary production by the energy impinging upon the plants for the purpose of the photosynthesis, then we can have an idea that how efficient the plants are in producing their primary productions. In this regard, we can see that herbaceous and forest communities are the most efficient communities of the plants for the primary productions, whereas the desert and the tundra ecosystems are the least efficient